Greetings, salutations, and welcome to my honest review of the E3D V6 hot end. Now, I had originally been planning to do a well-scripted and edited video, but some things changed since I recorded that, so I'm just doing it again from scratch in my usual impromptu manner. Now, I have contacted E3D with my concerns, including some points on the design where I've struggled to assemble it, and, a few other issues like that, and they have been very forthcoming and very communicative about what's happening and what they think, and it's been a good communication with them, so I can't fault them on that. They even sent me a replacement heat break because mine snapped, so that's good. Okay, so onto the main issue. I have had my E3D V6, the genuine item, for 4 weeks now, and the lack of content on the channel for roughly that span of time is basically due to the fact that I've been having absolutely terrible prints. Now, originally it wasn't so bad. Things like this test cone here, or in fact this one more accurately, these printed fine. These were through the E3D V6 on the direct. The green was on the Bowden, and as you can see, they're pretty good. That one's a bit worse off, but it's Bowden, and I'm not yet familiar with fine-tuning that. And yeah, it started out fine, but then I ended up discovering that that was failing on things like this, where you've got both printing at the same time, and it comes to a certain size of print area, basically. And basically what I think is what's happening is that the filament is heated up, it's printed, it's retracted, and it's still molten by the time that it's pushed forward again, and it just catches in the kinks and stuff. And yeah, that was my first worry with it, and the clogs that I unpicked seem to suggest that. However, after that snapped, I ended up moving on to a clone for a short while, which was also not doing very well. It failed on these. I then moved to another genuine replacement heat break from Ooze Nest. They are a supported and genuine reseller of the E3D parts, and it looked like that was going to work, but in fact it didn't. This was actually printed with that replacement part. This one was too, and at first I thought the issue was again just with the retraction and the timing on the dual setup. But then I got a whole load of these on single nozzle prints, and yeah, they've just become really, really stringy and thin and failed completely. So that is not a good sign. And what we have concluded from that is we did some cold pools. That's basically where you heat it up to about 200, stick some filament through, cool it down to 80, and then yank the filament out, and it's supposed to pull out any clogs, etc. But as you can see on areas like this, we have a small nub. Just a random little defect there. Another one here. And you'll notice that this area here is a bit more white and, well, shiny than others. And we have similar problems here. And basically by doing a volume calculation on those and looking at the official dimensions of the parts, we concluded that the issue was around the heat break here. Now this is actually a replacement PTFE. Here is a genuine E3D V6 heat break, all metal. So yeah, it happened about here. There's much more to say than that was where I was catching. That's where the clog was happening. It wasn't happening at the join between the heat break and the nozzle. That's where I expected it to happen. It was happening further up in there. And all I can surmise is that the PLA is somehow sticking or catching on it and, building up debris. We scraped out one of the older ones and discovered this kind of charred debris, which under a microscope showed a very crystalline structure, which suggests that it had been around there for a while and charged and built up. And that would have, caused the issues that we were seeing. So feeding on from that, the most likely and easiest to check culprit is that there is a physical defect within the bore. Either it hasn't been polished properly, or it's been mismachined somehow, and there's, just some small catch on it that's collecting debris. So the easiest way to check this is to use a piece of extruded filament and going in from this end, because it'll be easier to judge, we're basically going to push it in, and if it meets a catch, it'll bow slightly and I'll be able to feel the pressure difference as well as possibly see it. So this is the genuine E3D that I got a replacement. I'm feeling slight catches, but nothing too worrisome, I don't think. So now that I've got my genuine E3D as a datum, I'm going to check this, and this is a clone version that was bought much more cheaply. It's got a few differences in tolerance and stuff that make me worry about how usable it is. But just by poking this through, I can feel that while quite good, there's a bit of roughness and possibly a bit more than on the original. Now, one thing to note about these is you might be able to tell through the camera if I can position this well. These are two different sizes. The genuine item has a 2mm bore. It actually varies up to about 2.2, whereas this is 1.8. So basically, if your filament has a lot of variation in its thickness, it's going to get caught in this hot end a lot easier than in the genuine item. So that's something to watch out for. Now this one is a PTFE lined fake, and well, obviously the PTFE is there, but you can also tell by the heat break here and the fact that it is much thicker. So if we poke around in it as well, we should, and I would expect to find, that it is absolutely and completely smooth because it's PTFE. Now that is excellent if you are just printing normal materials. You'll probably just get away with a PTFE lined clone without any issues whatsoever. The reason that someone would use an all metal is obviously to reach higher temperatures. I'm not expecting to. I tend to just print PLA and other such materials because of the safety and the lack of risks involved in doing so. So I might end up having to use one of these clones, but for now I'm going to just test out this genuine E3D that I've been sent as a replacement, and we'll see how it goes. So here I have installed the replacement heat break that E3D sent, and I am printing something that I'm hoping to show you in an upcoming video if everything works out. But yeah, spoiler alert, here is proof that it's failed before. That was printed with the genuine replacement that I got from Ooze Nest. So we'll see how this goes. If it fails, I'll just have to go to PTFE. And the reason why I don't see initial issues when I do this is that when I push the filament through every time I unplug it, I basically purge a small amount, and that usually pushes through just enough of the charred material to let it print okay. And when I swap filaments, I do a much longer purge just to get rid of the previous colour. And yeah, that obviously cleans it out much better. So that's my theory as to why I don't initially see any issues, and it seems to happen higher up. But we'll see how this does. This is just a test piece, so it's not the most solid, but we'll see. So that came out okay, without any defects in the print itself. So that's looking quite promising. I'm now printing a dual cone, and we'll see how that goes. Well, that didn't come out too bad, actually. Surprisingly well. Wasn't expecting such a jump in quality. I'm noticing the very, very top of the yellow seems to have gone wrong, but that's not much. That's not much, and there's probably a few little things I can adjust to fix that without having to swap out the nozzle or the throat again. So we'll see how that goes with a different colour. I want to try a different colour just to make sure this wasn't a fluke of the yellow or something. Okay, so this is the sort of behaviour I'm talking about. We've only just begun the print, and if I put my finger against this, I can't feel it being pulled in. I can feel it being retracted, but it isn't pulled in. So obviously there's something wrong. I don't know, I'll try another filament. It might be the black. It's just an absolute pain, in which case I'll get refunded hopefully. But yeah, that's the kind of issue that I've been seeing over and over and over. So you can see it never really did finish off that bottom layer properly, and the end of the filament looks like that. See that kind of ridge on it there? Yeah, that's worrying. Okay, well, something's definitely gummed up. I just removed the black, as you saw, and inserted this beige stuff. Now, the beige stuff I've had for almost a year now, it prints beautifully. The only reason there's still so much of it is that, well, it's beige. And I'm going to try and do this single-handed so I can film it. But when I push down on the lever, and we're up to 210 degrees for this hot end, when I push down the lever and try to push that in, it does not go in, which means that we've definitely got a very serious clog there. And judging by the length of it, if I can get a decently accurate measure, it must be happening around the heat break area. So I'm going to take that apart again, and yeah, see what the damage is. So I've just removed it and I'm going to disassemble it now. To do that, I tend to use myself an adjustable wrench. Try to find things among my clutter. One of these, it's a ratchet with just a hex attachment 7mm across, and occasionally a few other things, but we'll see if this will work just as is. So, I don't know if you can see that, but it looks like we have a blockage within the nozzle, sorry, within the heat break there. The nozzle will obviously have a blockage as a result, but the worrying thing is that the blockage has continued up into there. So to remove that, I'm going to have to get out my patented heat break repair kit, which just consists of a piece of rubber to grip with some M7 and M6 nuts and this little pin, which is really good for pushing out material stuck in nozzles and heat breaks. So these are M7 nuts and I need M6s in this case, so we just screw those on like so, double tighten them, and if you find the right spanner, there we go, that's loosened it off just enough. Then naturally, to get these off, I'll just grip that there, loosen it off just enough. And there we go, and I think that E3D should include just 4 nuts like this in the kit so you can do simple repairs like that. But yeah, that's a definite issue. I'm going to try and remove that and we shall see how bad the damage is. And there we go. Now to note, it looks like there is still some stuck in here, but this is what we've got. I'm going to print another colour just to make sure that it's not just this filament. That's that up to temperature and the heat break cleaned out as best I can. So now I'm going to insert the beige PLA and we'll see if we can get it inserted all the way through. Yes, so it looks like we can. It looks like the heat has thankfully melted the very last, but there we go. So now to do another cone test with this filament and yeah, see if there's a difference and if my black's just of such a bad quality that it's exasperating any issues. Well, it's the next day and I've swapped out the heat brake for the PTFE lined one. And first I printed the black and green, which came out like so. It's not completely perfect up at the top, but come on, that is like a second or less on each of those layers. So that's pretty impressive. I then decided to check it on the beige to see if that's a fluke, and no, the same result. So that is wonderful. The only thing I've had an issue with, actually, is that the heat brake with the PTFE lining in it is about 0.3mm longer than the official one, which is a pain. But I've got 2 of those, so I'll just be swapping it out on the Bowden as well. Not the most ideal, seeing as the Bowden was working absolutely fine, but that should get things nice and level, and we can start. Now this here is the heat brake that it was in my Bowden, and it's the original that I was sent by E3D, and as you can see right through it, so nothing's stuck in there at all. That's wonderful. The nozzle as well, there's nothing stuck in there. Unfortunately though, because of the differences in length, I'm going to have to change them, but hey ho. And there we have it, a very stark contrast to the failure that was the E3D all-metal heat brake. Even the using has improved on this. So I'm really happy with that. I'm not happy with the fact that I had to end up using PTFE, but hey ho, what can you do? So that's been passed on to E3D. They're having a look at it. They're busy with other stuff right now, but hopefully that stuff includes a solution in future designs for this problem. So if you do have any issues like this, don't be afraid to pass them on to E3D. They're very accepting of these issues. Another print just starting. And yeah, I hope this has been informative, and I hope this helps you decide whether or not it's worth the money and the hassle if you think you're going to have trouble like I did with the all-metal heat brake. So thank you very much for watching, and I hope you'll join me again next time. Goodbye.